MicroMetl is pleased to announce we have expanded our 20-year relationship with Air Exchange. All MicroMetl ERV products now feature Air Exchange wheel or plate media. Air Exchange has served the industry for over 35 years. Their website is full of information on products, performance, and other energy recovery-related topics. In order to better serve our customers, MicroMetl has condensed our ERV product line. For comfort air applications of air-to-air energy recovery, MicroMetl has two offerings: a plate or fixed plate component, commonly known as a core, or a rotary component, commonly known as a wheel. Both mediums allow for heat or energy transfer between the exhaust airstream and the separated supply airstream. The Air Conditioning, Heating, and Refrigeration Institute provides standards for HVAC equipment. Historically, Air Exchange components were certified for performance across single points of operation. Air Exchange's industry-leading software allows for performance certification across the entire range of operations and will give you and your customers reporting on this performance in many different circumstances. This software is certified to the ASHRAE standard 1060-2018. The component's performance is certified by meeting the standard 1060 program requirements. This performance data is built into MicroMetl's online ERV configurator. MicroMetl ERV products allow for the reduction of HVAC ventilation load. This increases system efficiency and improves humidity control. Commercial spaces are increasingly required to bring in outside air for the improved health and well-being of the occupants in the building. MicroMetl ERVs will help lower the cost of lost energy from outside air by reclaiming energy in the exhaust air and preconditioning or tempering outside air fed into your system. When using ERVs to precondition outside or fresh air into your space, building operators can still enjoy lower building operational costs while still meeting building mechanical codes. This is a basic energy recovery device. It contains 4 quadrants with energy recovery media separating them. Outdoor, or OA, enters the first quadrant and meets with the energy recovery medium. It passes into the second quadrant and is now called supply air, or SA. SA can exit the ERV into the HVAC unit or directly into the conditioned space. After traveling through the space, the conditioned air will now be labeled RA, or return air, and enter into the third quadrant and meet again with the energy recovery medium. The air then enters the fourth quadrant as EA, or exhaust air, and exits to the outside. Let's take a look at this wheel example. In summer conditions, the OA has a 95-degree dry bulb or 78-degree wet bulb condition. The return air comes back from the system at 75 degrees dry bulb and 63 degrees wet bulb. The impact of the ERV and its energy recovery can be seen in the SA, or supply air quadrant, with an 81 degrees dry bulb and 68 degrees wet bulb temperature. In winter conditions, the outside air enters the system at 7 degrees dry bulb and 6 degrees wet bulb. The return air is 72 degrees dry bulb and 54 degrees wet bulb. As the outdoor air passes through the energy recovery medium, the temperature is raised by mixing it with the return air from the space. The result is a 53-degree supply air to the HVAC system or space, rather than a 7-degree supply air, which would be the case without an energy recovery solution in the system. ASHRAE standards drive building codes. Many local, state, and national governments require code enforcement on new construction. ASHRAE Standard 62.1 is concerned with ventilation for acceptable indoor air quality and is widely used in the HVAC industry. ASHRAE Standard 90.1 is the energy standard for buildings. Use of energy recovery products help building owners to meet these codes, such as the LEED Green Building Rating System and the International Energy Conservation Code, or IECC. Enthalpy recovery ratio versus effectiveness. As time has passed, the terminology for energy recovery has changed. For many years, effectiveness was the standard terminology. This has been replaced with enthalpy recovery ratio. One major reason for the change is that effectiveness formulas varied between ASHRAE and AHRI prior to 2019. The enthalpy recovery ratio formula more accurately accounts for energy recovery in different scenarios such as differing airflows for supply and return air. ASHRAE Standard 90.1 2019 requires a 50% enthalpy recovery ratio for cooling and a 60% enthalpy recovery ratio for heating. This is a weather zone map of the United States. When talking about energy recovery requirements, there are temperature zones 1 through 8 and humidity zones A, B, and C. Each city in the United States in a zone will have both a number and a letter. For example, Indianapolis is Zone 5A. This is an updated map from ASHRAE in 2013, where some of the zones have shifted across the United States. This is based on adding in more current weather data to the map. This map will be used as the basis of building codes in the near future. This new map adds new requirements for the additional zones. System designers need to be cognizant of the new requirements when specifying or recommending building equipment. Here's an example of two tables from the International Energy Conservation Code, which references the ASHRAE Standard 90.1. The code has different requirements based on ventilation systems operating less than 8,000 hours per year, which is located in the top table. The bottom table shows requirements for ventilation systems operating over 8,000 hours per year, such as buildings that are open 24 hours a day and 7 days a week. The chart represents when an ERV will be required by climate zone, the amount of ventilation or outside air as a percentage of the HVAC system's total airflow, and total CFM by volume. When looking at this map again, different climate zones may be better for different types of energy recovery products or media. Keep these considerations in mind when planning your equipment for projects in these zones. The key factors to consider from a design perspective are the climate zone in which the project is located, the airflow rates in CFM. Uneven airflow rates will have an impact on enthalpy recovery ratios and may lead to a more difficult time in reaching standard or code requirements. The performance over the service life of your unit. Be sure your design leaves access to the unit for cleaning and maintenance to ensure that the performance standards will be met throughout the life of the equipment. Here are some key features of the MicroMetl C and F Series ERV units. These units use a plate media from AirExchange. This media features a selective porous membrane and has an excellent gas barrier, as well as antibacterial properties. Humidity will not cause this media to deform or lose its structure. AirExchange also offers a 5-year warranty on the plate media. The MicroMetl wheel cabinets feature a polymer energy transfer media, with segments for ease of cleaning and maintenance. The stainless steel construction will have strength to last for the lifetime of this media. AirExchange also offers a 5-year warranty on wheel media. Other related ERV products and options include roof curbs, including knockdown, welded, or vibration isolation styles in 3 base heights, high-efficiency ECM motors, which have backward inclined fans and allow for variable airflows, easy ERV airflow monitoring featuring a micro coprocessor controller and an operator interface. This controller also has options for BACnet or building management systems. Configure all these options for your next energy recovery project at micrometl.com.